I'd like to talk about two things today. One is succession, and another is a possible management scheme for old growth forests. And succession is kind of a lead into that. Succession the concept was first proposed by Frederick Clements in the 1920s, and he defined it as a natural progression from one ecological state to another until you hit what is called the climax state, which is the end point of succession, or at least it's the end point until you have a disturbance. And a natural disturbance would be something like a fire or a flood that would wipe out your forest, and an unnatural disturbance would be something like a clear cut. And one of the things that he defined was primary succession. Primary succession is the establishment of plants in an area where there was never plants before. The establishment of plants on bare rock, like you would see in a newly formed volcanic island, or that you would see in a newly formed mountain range. Once you have bare rock, things like lichen and mosses become established on it. And when they become established, that contributes to soil formation. And once you get soil formation, you begin to get flowering plants, and you get what are called pioneer species or weedy species that begin to move into the area. But they also contribute to soil formation and add nutrients to the system. And so with enough time, you finally get your climax community, which is your endpoint of succession, until you get a disturbance such as a fire that could come in and move through the area. Well, we're going to be talking about secondary succession, which is the reestablishment of a forest after a clear cut has been conducted. It's not primary succession because the plants that become reestablished are not becoming established on bare rock. There's already soil in the area. And so the clear cut would be the unnatural disturbance that would start the process of succession going. And so here's an area in Washington that was probably cut the previous year, and you can already see shrub seedlings and grasses becoming established. And so these would be your pioneer species, your first species to move in after the disturbance. Given time, you eventually get tree seedlings that get established in this area. And those tree seedlings will eventually, given 140 to 160 years, will be able to develop into what's called a mature forest. And note this picture of a mature forest looks very different from an old growth forest. All the trees look like Christmas trees. We have a very tight canopy. We don't have a multi-layered canopy. We don't have trees of different sizes and ages. We don't have dead standing trees or snags. We've got a very tight canopy of trees that look like Christmas trees, which means very little light would hit the forest floor. Then you hit your climax stage, or your end point of succession, which would be your old growth forest. And for a forest to start having old growth characteristics, you need about 175 to 250 years. This obviously has been around longer than that because this Douglas fir is probably somewhere between 500 and 1,000 years old. And so I'd like you to note the difference between mature versus old growth forests. Mature forests, it looks like Christmas trees. You have a tight, closed, one-story canopy. With an old growth forest, you have a multi-layered canopy. You have trees of different ages and different sizes. You have snags and you have downed logs. Recall that snags are dead standing trees. In a mature forest, you have uniform cylindrical trees. They look like Christmas trees. In an old growth forest, since you have snags, dead standing trees, and down logs, you have light gaps in the canopy. And because of those light gaps, You can get shrubs established where the light hits the forest floor, so you have understory diversity. Whereas in a mature forest, since you don't have light hitting the forest floor, you don't have a lot of shrubs or understory on the forest floor. And so just some pictures to show the difference. Here is a picture of an old growth forest next to a mature forest. There's a lot of habitat similarity. Many species that use old growth forests for habitat can also use mature forests for habitat. Compare that with an old growth forest next to a clear cut. A huge difference in habitat types, a huge difference in species composition. Species that would use old growth forest as their primary habitat would probably not find an area after a clear cut is a very suitable habitat. Also notice the stages of succession from clear cut to the seedling stage, to the mature forest stage, to the old growth forest stage. And so Larry Harris wrote a book called The Fragmented Forest, which is a possible management scheme for existing old growth forest. And the book describes a system for regulating the timber cut on very large tracts of land based on island biogeography, and also based on some of the concepts of the design of nature reserves that we talked about earlier in the course. And so I want to talk about a few relevant sections of the book. And one of the things he talks about is the advantages of having an old growth stand next to a mature forest stand. When you have an old growth forest stand next to a mature forest stand, you have habitat similarity. And so this can be supportive habitat for species that inhabit old growth forest. And it also buffers the climatic effects and mitigates edge effects. And older trees are less susceptible to fire, and so it actually acts as a buffer to fire that could impact your old growth forest stand. And so if you have a mature forest next to an old growth forest, again, there's a high degree of overlap in species that use old growth forest as a primary habitat and those that use mature managed stands as primary habitat. Whereas if you have an old growth forest next to a clear cut, you're maximizing the climatic differences. So this would be very dry. This would be much more humid, just like deforestation around a tropical rainforest. You have maximum habitat differences for wildlife, and you're maximizing the edge effects. And recall, in terms of edge effects, if you have a clear cut next to an old growth forest, remember that wind penetrates 2 to 3 tree lengths from the edge. And so that is going to impact the humidity, and you're also going to get tree fall due to that wind. And so if you're looking at effective habitat size, if you're trying to preserve old growth forest, to preserve the animals that inhabit an old growth forest, effective habitat island size is influenced by 3 factors. One, obviously, is the size of the island. Think of your species area curves. 2 is the distance from a similar old growth island. And 3 is the degree of habitat difference between the islands. And so a mature forest will act as a buffer zone, and it will protect the old growth stand from wind effects because that wind penetrates 2 to 3 tree lengths from a clear-cut edge. And a mature stand that surrounds an old growth island may act to increase the effective island size of an old growth patch through habitat similarity. And so Larry Harris proposed a system of long rotation islands. And so you have an old growth core with 9 replacement stands around that old growth core. And then at 35-year intervals, you're going to clear cut one of those 9 replacement stands. So each 35 years, you'll do a clear cut around that old growth habitat island. And so here is a drawing of the proposed way to do the clear cuts. So here we have our old growth island. T0 stands for time zero. This is where we're going to do our first clear cut. And then 35 years later, we are not going to cut the next piece of pie, but we're going to skip over to number 2. So we've gone from here, number 1 at T0, to number 2 at T35. And that is going to be when we do our next clear cut, 35 years later. If we go from 1 at T0, we skip over to here, 2 at T35, and 3 here at T70, okay? 70 years from T0, we're going to do our third clear cut here. We'll do our fourth clear cut here. We skip over and do our fifth clear cut here. We skip and do our sixth clear cut here at 180 years. Our seventh clear cut here at 250 years. 215 years. Our eighth clear cut here at 250 years. Our ninth clear cut here, this is the ninth area to be cut, and our 9 pieces of pie at 285 years. And so notice when you start the whole system over, it's 320 years before you do a clear cut on that original island, which has given this area to develop really good old growth characteristics. And so the island consists of an old growth core and 9 replacement stands, and you cut every other piece of the pie every 35 years. With this rotation system, it will ensure that 66% of the surrounding buffer stands are greater than 100 years old. So they're approaching being a mature forest, okay? And this is kind of a diagram showing you here's the first cut at T0. 35 years later, you're doing your second cut, and you're already getting succession on your first cut, where you're getting young tree seedlings on that first area. And recall that by 285 years, you're going to have old growth characteristics. And so to summarize, we have our old growth islands in the core, in the middle. And to enhance an old growth island's effective size, you should aim to have mature stands border old growth islands to act as a buffer zone. Recall that it takes 175 to 250 years for old growth to develop. And so if you have an old growth core and 9 replacement stands, and you cut a replacement stand every 35 years, 66% of the buffer stands are greater than 100 years old. Then the other thing he proposed is to have, your larger old growth islands at lower elevation, okay? And he also proposed having riparian areas as corridors. Riparian vegetation is a vegetation that borders a stream. And so here you can see the stream at high elevation. Notice that streams are smaller at high elevation. As you go down the mountain, your small streams merge to create longer streams. And if you get low enough, you get enough streams merging to form a river. And your best habitat is at low elevation, and so you're going to have larger animals like bears at your lower elevation sites. And so anyway, lower elevation sites are better habitat for wildlife if you compare them to high elevation sites that have a lower temperatures and a shorter growing season. And then he proposed riparian areas as corridors. So this is a riparian area in the Eastern Sierra and McGee Creek. Riparian areas are characterized by having deciduous hardwood trees, winter deciduous, which means they drop their leaves in the wintertime. These are flowering plants compared to conifers, which are not flowering plants. So here we have willows and aspens, which are flowering plants, which provide food for wildlife. And so riparian areas end up being important wildlife habitat. Okay. And so riparian areas are dominated by deciduous hardwoods that provide much more food for wildlife than conifers. And then this is showing you, this is a picture trying to show you a watershed. I've shown you this picture earlier in the course. Here we're in the Sierra Nevada. Here we're high elevation, and we have very small streams merging into larger streams. These larger streams merge into small rivers that eventually merge into larger rivers. And so here we have the Feather River merging into the Sacramento River. Okay. And so if you use these riparian areas as corridors, that facilitates genetic exchange between animals that live in different watersheds. Okay. And so anyway, he proposed riparian areas as corridors because they contain permanent water. They're dominated by deciduous hardwoods, which produce nectar, fruits, and seeds, which support abundant wildlife. They receive nutrients from upstream and transport that downstream, and then they extend vertically up and down the slope. And so again, the top of this drawing represents high elevation. As you move downstream to lower elevation, your lower elevation sites are going to have more water and higher nutrients and warmer temperatures, and they're going to support higher species diversity. So this is a picture from his book, and it's a little confusing. But here we have the Diamond Peak Wilderness. This would be a high elevation site. And as we go down the mountain, the streams merge and get bigger and bigger till we get to low elevation site where the streams merge enough to create rivers. And so here we have a river at low elevation. And as we move up here, we're moving to higher and higher elevation. And the squares represent habitat islands. You can relate those to those old growth core areas. And so notice he proposes having larger old growth habitat islands at lower elevations. You want your largest old growth habitat islands at your lower elevations because that's the best habitat for wildlife. And then again, notice we're using riparian areas as corridors between those old growth habitat strips. So that is a summary of both succession and Larry Harris's management scheme for old growth forest, and I hope you found that helpful.